Hi, boys and girls. Today's video is over section 4.3. These are the practice problems at the end of the chapter. You want to be looking on page 211. Okay. Practice problem number 1. The graph of line M is shown. Use the similar slope triangles to compare the slope of segment RT and TV. Okay. So they want us to compare the segment RT with the slope of TV. Now we know common sense tells us that because these are two parts of the same line, they're going to have the same slope. But they want you to find the slopes of those two segments to prove it. Okay. Well, remember when we're finding slope, we always want rise over run. Okay. And that's the change in y over the change in x. Okay. Start with the leftmost point. So we're going to find RT first. Okay. Slope of RT, line segment RT, is from R to T, we have to travel up first, and we go up 2 spaces. So that is a positive 2. That is a positive 2 change in the y direction. We went up and down. We went up, so it's positive. Going from this point to T, we travel right 1, 2, 3, 4 spaces, and that's a positive 4. Now keep in mind we always have to reduce our slopes, so this reduces to 1/2, right? Now let's find the slope of TV. Oh, now it looks like what, 4? Is that 4 Roman? It's TV. All right, starting with T and traveling 2V from left to right, we go up 1, so positive 1 on top, and we go right 2 spaces, which is positive 2. When you enter this in the computer, though, you're going to want to drop those plus signs and just enter it as positive 1/2. You'll notice that the slopes of the two line segments are the same. And that's like the whole point of the thing, I guess. Okay, example 2. The plans for a zip line are shown. Use 2 points to determine the slope of the zip line. Then verify that the slope is the same by choosing a different set of points. So let's do from this point to, that's nice. This is the hardest part of this thing, is drawing straight lines. Do that one. And then we will also do one that goes from B to D. Okay. So our first line segment is line segment BC. Traveling from this point to this point, notice we have to go down, all right? We have to go down 1, down 2. Movement down is always negative. So the change in y is down 2. Then the change in x is this one, and it's right 1, 2, 3, 4, 5, 6. Right 6. This reduces to 1/3. And remember, when you put a negative fraction in reveal, you put the negative sign out here, and then you type the fraction. Now, let's look at BD. We could, no, you know what? Let's do CD. That will be easier. That'll be more like the example in the book. Let's do it that way. Okay. Let's go from C to D. Like that, make a little triangle. A little messy triangle. Okay, to go from C, which is the left point, to D, the right point, our first move would be to go down 1. So for CD, we go down 1, and then we go right 1, 2, 3, which is positive 3. So we would type this slope in the computer as a negative 1/3. Notice that they have equal slopes, and that's the point we're supposed to make, is that they have the same slope. Of course, they have the same slope. They're on the same line. Slope doesn't change. Oh boy, now we have a lot of slope triangles for number 3. Name the slope triangles shown in the graph. What is the slope of the line? Well, when you name triangles, what you do is you write the symbol triangle first, and then you put the 3 letters that make the triangle. So if we were going to do this one here, we would go maybe CGF, triangle CGF, that's one. We also have this little guy here, this little one here. This is triangle BID, BID. And then we also have this big triangle here, this one here, EHA. and they want to know what the slope of the line is. Well, we can find the slope of the line by just choosing 2 points and traveling from the left point to the right point. Okay, so let's just say we chose these two. All right, our first move is always up or down. To go from C to D, our first move is to go up 1. So our slope has a top of +1, and on the bottom we go right 2, and that's +2. Now you'll notice the bottoms are always positive. That's because we're going from the left point to the right point. Because of that, our second move is always right, and right is positive. Now, if we were doing this willy-nilly however we wanted, the bottom number would be negative if you had to move left. All right, but if you always go from the left point to the right point, the bottom number will always be positive, which makes math a lot easier when you have fewer negatives. Draw 2 slope triangles on the line. Determine the slope of the line. All right, so when we're drawing these slope triangles, we're looking for exact crossing points. There's an exact crossing point. That looks like an exact crossing point. Now, when I say exact crossing point, like look here, this is hitting in the middle of a line here. I'm looking for a point where the line passes through an exact X. And it looks like this one only has 3 points that are exactly on intersections. Okay, so what we can do is we can travel from this one to this one, and then we can travel from this one to this one. All right, so starting from here, remember, change in Y is the top number, change in X is the bottom number. Our first move is always up or down. Up is positive, down is negative. So we're going to go up 1, 2, 3. So up 3. So the top number is +3. The bottom number is how many do you go right? 1, 2, 3, 4, 5. And +5 because we went right. For the second triangle, we would start here and we would go up 1, 2, 3. And then from here we go right 1, 2, 3, 4, 5, which is what we expected. The slope of this line is 3/5. Number 5. The graph shows similar slope triangles on a line. Select all the statements that are true. First of all, the slope of the line is negative. Yeah, slope do call that a nice negative, so that's true. The slope, well, I guess I should probably put an X. Probably should put a check, right? I guess it doesn't matter. Uh-oh, what did I do? Yep, let me go back. Oh, there we go. We'll do a check. The slope of the line is negative. Check. The slopes of each triangle are the same because they lie on the same line. That's what I've been saying. Everything's on the same line. Triangle CDE has a greater slope because the triangle is larger? No, it has the same slope. Okay, it's just bigger triangle. The slope of each triangle is 2/3. Well, let's see. We'll find the slope from this point to this point. All right. Starting from the left point, we go down 2. So the top number would be down 2, and the bottom number would be right 3. This has a slope of -2/3. So is this one correct? Not really. This says it has a positive 2/3 slope, and Slope Dude will tell you that is not a positive. That's not a puff positive. And the last one says the slope of the line is positive, which we also know is not true. So the only 2 correct statements are the first 2. Okay, lines R and S are parallel, meaning they will never intersect. Draw similar slope triangles on each line and find the slope of each line. What conclusion can you draw about the slopes of parallel lines? Well, what do you think you're going to find about the slopes of parallel lines? Slope measures how fast is it changing. Doesn't it seem like it would be the same? I think it would be the same. But let's check it out. There's a slope triangle. There's a slope triangle. All right, change in Y over change in X. Going from left to right, first move we would go up 1, +1 on top, and right 1, 2, 3 spaces, +3 on bottom. Over here, going from this point to this point, left to right, we go up 1 first, and we go right 1, 2, 3. So not really surprising. I think we kind of saw this coming. Parallel lines have the same slope. Parallel lines have the same slope. Now the next question is going to ask you about perpendicular lines. Doesn't it seem like they should have opposite slopes? I think so too. Lines M and N are perpendicular, meaning they form a right angle. Draw similar sloped triangles on each line and find the slope of each line. What conclusion can you draw about the slopes of perpendicular lines? Well, let's see. Here's a perfect crossing point. Traveling out here. Oh, there's another one. All right, so traveling from this point to this point, I go up 1, 2, up 2, and I go right 1, 2, 3. So this line has a slope of positive 2/3. Now let's find the slope of this line. Let's go from this point to this point. All right? Starting from the left point, we have to go down 1, 2, 3. So we went down 3, and then from here we went right to positive 2. So this line has a slope of negative 3/2. So on the last slide I said, don't you kind of expect the slopes to be opposite? More than opposite, perpendicular lines have slopes that are negative reciprocals of each other. Okay, this one has a slope of positive 2/3. The other one has a slope of negative 3/2. Okay, they're flipped over. The fraction is flipped over, and if it's positive, it changes to negative. If this had been negative, this would have been positive. But what do you do when you have a slope of, say, 5? Okay, well, we all know that there's really an invisible 1 under this 5, right? So the negative reciprocal of 5 is negative 1/5. You flip this over and you change the sign. A slope of, say, negative 7 would have a negative reciprocal of positive 1/7. We flip it and we change the sign. Okay? Perpendicular lines have negative reciprocal slopes. All right, I don't like number 8, how are slope triangles, corresponding sides, ratios, and rise run related. Doesn't sound like fun to me. I do like number 9 though. A student found the slope of one segment on a line to be 4. Okay, so we have a slope of 4. Another student, and the slope of another segment on the same line to be 8/2. He concludes that the slope is different at different points on the line. Correct his thinking. Well, what did he forget to do here? He forgot to reduce this. This reduces to 4. Therefore, the line has the same slope throughout any straight line has the same slope on any part of that line. No matter how big or small the part is, the slope will be the same. I think that's it. That is. So that's all we have for this video. A nice short one. You're welcome. All right, go on over to McGraw-Hill and complete the practice assignment, and I'll see you in class.